Hi, good morning everyone. This is Sheikh Mohammad Rafi, Assistant Professor, Department of CS, Annamachal University. Today, I would like to explain Apriori Algorithm in the subject the data mining, the concepts and techniques. What is meant by Apriori Algorithm? Apriori Algorithm is a level by level search algorithm where k item sets are used to explore k plus 1 item sets. It is a frequent item set mining methodology. Here, we can use two measures in order to find the frequent item set. Support and confidence, they are the interesting measures. They are used to find the frequent item sets. A priori algorithm is also a two-step process, which is a join step and pruning step. A priori algorithm is having a transactional database, and this database having 4 transactions, that is transaction ID 10, 20, 30, 40. And each transaction is having a list of items that are bought by customer here: ACD, BCE, ABC, and B. First we have to find the candidate 1 item set. What is the meaning of candidate 1 item set? A candidate preferred a list of 1 items where a set is consisting of only 1 item. So in order to find the candidate 1 items, we have to scan the database to know the count of each and every 1 item set from the transaction database. So A is occurred 2 times in transaction 10 and transaction 30, and B is occurred 3 times in 20, 30, 40, and C is occurred in 3 transactions, that is 10, 20, 30. In such a way, we listed all these frequency counts of this candidate 1 item set. So we just put the minimum support 1 value 2, means that a customer who buys an item may likely buy another item. In order to find the frequent item set, the minimum support 1 value we kept that 2 here. So you compare each candidate 1 item set support 1 with the minimum support 1 value. So whatever the item set which is not satisfy minimum support 1 value, that item set should not be considered as a frequent 1 item set. So in order to discriminate the candidate 1 item set and the frequent item set, we just literally used the terminology C1, L1, C2, L2, C3, L3. So what is the meaning of C3 here? A candidate who preferred a list of 2 items. By scanning the transaction database, that we found this count here. Whereas L2 means a list of 2 items after scanning, which is compared with the minimum support 1 value. If it satisfies the minimum support 1 value, that set can be considered in L2. If it is not satisfies the minimum support 1 value, that can be pruned from your transactional database or from your candidate item set, candidate K item set. So that is called as pruning. Pruning means deleting if it is not satisfying the minimum support 1 value. So out of all these 5 1-item sets, 5 candidate 1 item set, 1 item set, that is D, is not satisfies the minimum support 1 value. So 1 less than 2 here. So we just delete from this L1 here. So after the successful completion of first iteration, we just found A, B, C, E candidate 1 item set satisfies minimum support 1 value. Now it is taken as L1. 2, 3, 3, 3. So we'll go for second scanning here. So candidate 2 can be generated by joining of L1. Candidate 2 can be generated by joining of L1 cross L1 here. So L1 is joined by itself here. So that is called as candidate 2. So A, B, A, C, A, E, B, C, B, E, C, E. So if you have 4 L1 item sets, we can generate here 1, 2, 3, 4, 5, 6 C2 item sets. So AB you got AC, AE, BC, BE, C. Now you just scan the database for the second time in order to count the frequency count of each candidate 2 item set. So AB is occurred how many times here? So AB is occurred how many times here? AB is occurred only 1 time in transaction 3, and AC is occurred how many times? 2 times in transaction 1 and in transaction 3. So the count of AC is 2, AE is 1 and BC is 2, BE 3 and CE 3. Similarly, you scan all these candidate 2 item sets from your transaction database. So that is 1, 2, 1, 2, 3, 2 you got here. So the count of AB and AE 1, 1, which are not satisfied the minimum support 1 value 2, you just prune from the candidate 2 item set. So because the frequent 2 item set cannot be taken as the less minimum support 1 value here. So only AC, BC, BE, CE. will be considered in the L2 here. Finally, the candidate tree item set can be generated by joining of L2 and by itself here, joining of L2 and itself. So AC is not going to be joined with any other item set because no item set that are started with A here. There is no item set having predecessor A. So AC left out from the candidate tree item set. Whereas BC is having one more pair here B. So BCE I can form as a candidate tree item set. So that is whereas the CE doesn't have one more pair. There is no predecessor item set started with the C here. So that item cannot be paired with another item set. That cannot be considered as item set candidate 3. That is candidate 3 item set. So only one item set I got BCE. Now scan your transaction database for the third time here in order to find the support count of candidate 3 item set. BCE I got only transaction 3. That is transaction 30 here. So its support count is 2 and the support count of candidate 3 item set BC satisfies the minimum support count value. So that can be considered L3 here. So algorithm stops here and no more item sets are going to be found here. So that is BC is the final candidate 3 item set and also frequent 3 item set. So finally, this item set is satisfies the minimum support count value. So once you find that frequent item set, which is frequent 3 item set, you check an item set is consisting of 3 items here BCE, whether this item set is a strong one or weak one or not. So that is how to find the item set is strong here. So you check the support count of this item set satisfies both minimum support count value and also minimum confidence, which is the probability which is kept by the domain expert, the threshold that can be given by market manager, market executives, market business analysts. They can put the minimum confidence value here. So the support count 2 is satisfies the minimum support count here. So it is taken as L3 frequent 3 item set, and this item set also satisfies the minimum support minimum confidence value, and that item set can be taken as the strongest association rule. So once you find this frequent 3 item set, you convert this item set into an association rule analysis, which is an attribute value pair, which is in the form of A implies B, where A is a database and B is also a database. Both are consisting or comprising of a set of items. Maybe that a customer who buys B may likely buys C, a customer who buys C may likely buys B, a customer who buys E may likely buys BC. So association rule analysis is an implication form of A implies B. And A part can be called as if part, which is a antecedent part, and B part can be taken as a consequent rule, which is a then part. Like I want to compare this example with programming concept. If the condition is true, the statement under if will be executed. If the condition is false, the statement under else will be executed here. So that is, a customer who buys B may likely buy C or not, may unlikely buy C. So that probability that we are going to find out here, so that is called as B and C. B implies C and E. So there is one more choice here. A customer who buys AB, a customer who buys AB may likely buy C. A customer who buys AC may likely buys B. A customer who buys BC may likely buys A. So if part may consist of 2 items and then part may likely contains 1 item, or if part may contain 1 item, then part likely having 2 items. It is vice versa. So I want to find out the confidence of this rule, and that should be compared with the minimum confidence rule, either 50%, 60% or 70%. Then out of these 6 rules, A implication, B rules, we can find the set can be taken as the strongest association rule. So you just scan the transactional database for finding the confidence of B implies CE. So what is the formula for B implies CE here? So support of B union, that is A union B, by support of A. So what is the support of A here? What is the support of A? That is, left side part can be taken as A part, right side part can be taken as B part. Here A means B, left side we have A, B item here. The support of B is 3. So 3 divided by 3 union BC. Support of A union means BC. BC means that is 2 times support 2 by only support count of B here, that is B. 2 by 3 means that is 66.66 percentage. So if the threshold value is 60%, so this item set may be qualified as a strongest association rule. Finally, I would like to conclude that a priori algorithm is a frequent item set mining method which is used to find k item sets by exploring k plus 1 item sets, and it is having a joint step and pruning step, which is a two-step process. So